So today we'll talk about logical operator. Okay, and we did discuss about the truth table. Okay, let me see if I can figure out where the truth table is. No, I think, did I save it? I think we did not save it, right? So no problem, we'll do it again. Okay, so we discussed about and. Okay, and what we said was, we said that all, okay, all value and is an operation. So visualize and like plus. Okay, so when you talk about operator, okay, or operation, okay, you need values, and between the values you have operator, right? So if I talk about let's say and operator, so on either side of and you have to have a value, right? So logical operator works on Boolean and returns Boolean only. So your here all values have to be true to get the final result as true. And if you talk about OR, okay, all values have to be, okay, no, any one value. Any one value is true, you get final result as true. Okay. Okay. So now between and or, which one should you do first? So how do you remember is, okay, this is how I remember. And is very similar to multiplication, and or is very similar to addition. Okay, because if you have like 5 into 99 into 7 into, okay, this is into, you know, 151 into 45 into 0, what do you get?
0.
Right? So even if one false is there, entire thing becomes false. Your and, okay, even one false is there, entire thing becomes false. And here, if you have 0 plus 0 plus 0 plus 0, okay, you have all zeros, but if you add 1, it becomes 1, right? If one value is also 1, entire thing will be 1, non-zero, right? So this is how I remember, okay? So if you look at, so this is how, multiplication and addition works, right? So if you multiply a number with 0, even if one number is 0, entire thing becomes false, right? Okay. Now, tell me what will be the output of this. If I say print true and true and false, or true or true and true, or false and true and true, or false. Okay, what do you think the answer will be?
False.
False. Okay, let's try to solve it. Okay, let's try to solve it one by one. Okay, So first, which one should we solve? First, we have to solve all and, isn't it? Let's copy and, paste it down and try to resolve one by one. First, we have to solve and, isn't it? Because and is like multiplication. So what is true and true?
True.
True. Okay. True. What did we say? All values have to be true to get the true. Both were true, isn't it? Now, true and false.
True.
All values have to be true. Is it all value true? No. It is false
It's
only.
false.
Zero. False is like zero. Zero multiplied by anything is zero, isn't it? Zero is false. Non-zero is true. So zero into anything is zero only. Again. So multiplication. First have to solve multiplication. What is true and true?
It's true.
True. Yes. Then false and true. Zero into anything?
False.
Yeah, zero into anything is, you should be fast now. False and true?
It's false
False.
also.
Yes, false. Okay, now all or is left. So let's solve or. False or true?
It's true.
True. Even one true, its entire thing is true. True or true?
It's true.
True. False or true?
True.
True. Even one true, it's true. True or false?
Oscar.
True or false?
True.
The entire thing should be true. Let's run it and see. P1. Okay, you get true. So this is how your AND works. Yes, this is your logical operator. Now you can see in this way. Let's say I put num1 equal to 5, num2 equal to 8, and I say print num1 not equal to num2 and num1 greater than num2 or num1 less than equal to num2 and num2 greater than equal to num1 or, okay, let's say num2 or num1 and num1 equal to num2 and num1 less than num2. Okay. What do you think this is going to be? Okay, I'll give you a few seconds to think and then we'll solve it, okay? Okay. Now let's see. Okay, let's see. Num1 not equal to num2.
True.
True?
Yes.
Num1 greater than num2.
False.
Num1 less than equal to num2.
True.
Num2 greater than num1.
It's true.
Yes, 8 is greater than 5, correct? Yes. Num1 equal to num2.
No, like false.
Num1 less than num2.
Yes, true.
Okay. Now you solve OR and T and F. F,
F.
yes. T and T,
T.
F and T,
S.
and now F or T,
E.
T or F.
E.
Yes. So when you run it, you get true. So this is how we use logical operators. Okay. Okay. What is binary values? What is binary values, guys?
Zero and one.
0 and 1? Right.
No.
Okay. Correct. 0 and 1. So numbers that are made by 0 and 1. So if you have to convert a decimal system to binary, we have a function called as bin. Now we're talking about one more function. Okay. One more function, which is your bin. Okay. So what does bin do? Bin of, let's say, 18 I give. Okay. Let's say I give num1 equal to, and I print num1. Okay. Or let's use num3, different variable. Bin is a function that will convert whatever number into binary format. So what is equivalent of 18 in binary? 0b is indication that 0b is indication that the number that you have is binary. If it did not give, okay, if you did not give 0b, it would mean that then it will be difficult to find difference between binary or a decimal system, isn't it? So if I write 10010, how do you know it is binary number or a decimal number? So if you do not see anything in front of a number, if you do not see any sign or symbol in front of a number, it means it is decimal number system. And if you see 0b in front of a number, it means it's binary number. Clear? Similarly, you have hex is for hexadecimal system. Okay, so if you say hex 18, it will give you equivalent of 18, which is 0x. Okay, so 0x indicate hexadecimal. 12 is the 18 equivalent in hexa. 18 is written as 12 in hexadecimal. Okay, and 0x indicate that it's a hexadecimal. Okay, so you have bin, you have hex, and similarly you have octal number system, OCT. OCT is 0O. It is 0O. 0x is hexa, 0O is octal, 0b, and all small letters. Okay, B is small, X is small, and O is small. So you'll have first 0 followed by small letter. It could be B, X, or O, followed by the number. Clear? So this indicates different number system, right? Now let's say I have a binary. I want to convert into hexa. Of course you can do. So first, how do you know it is a binary? So you will give 0b, correct? Followed by, let's say you have 110 1111. Let's say this is a binary number. So you say hex. Hex can convert any number into hexa. Need not be only decimal. So hex of this will give you 0x6f. 6f is the actual notation in hexa. Okay. You want to convert into integer. Okay. Simply say int. Int not only converts string into integer, that's what we saw yesterday. Not only converts string into integer, but it also converts any data type into integer. Okay, so 0b110 1111 will give you 111. So see, there is nothing in front of this. That means it's a decimal number system. Is it clear? Fine. So now you should be able to convert any number system into any number system. Yes, no? Now 4 people, only one yes.
I didn't get it, sir.
What you didn't get?
Hex and octal.
No, tell me what you didn't get.
Why we are giving like OX and OO?
This is a hexadecimal system.
So with that, like what we need to prove?
You don't need to prove anything. Oh, okay.
Sir,
By looking at, I'll answer you, Bala. Wait. By looking at dosa, can you know it is dosa? Yes or no?
Yeah,
Yeah. So by looking at dosa, you can know it is dosa. By looking at number, can you find out whether it is decimal or binary or hexa or octal?
yes,
And
we can.
how?
If there is any point in between the numbers, we like we know that it's decimal.
That is float. Decimal number
Ah,
system
right.
is that,
Float.
yeah. So decimal number system is the number system where you use 10 numbers. Okay, 0 to 9. Binary is a number system where you use 0 and 1. Hexa is a number system where you use 0 to 16 letters. So A, B, C, D, E, F. 0 to
Okay.
F. Octal is a number system where you use 0 to 7. So by looking at number, how do you know it is octal or hexa or binary or decimal?
Yeah, all right.
So you see, if there is nothing in front, then it is integer, decimal. If there is OX, 0x, not OX, 0x, it is hexa. If it is 0O, small o, it is octal number system. 0B, it is binary number system. And you can convert into these 4 into each other type. By using int of anything, you can convert into integer. Whether it is boolean or hexa or octal, doesn't matter. Using hex of, you can convert any number system into hexa. Yeah. Okay. Using OCT of, you can convert any number system into octal. Yes, no?
Yes.
Yeah, Bala, you are saying something.
sir, how to came 0x12 and 022?
This is coming from here, no? Hex, we can
So,
say
but like,
here,
what
hex
my
equal
point is,
to OCT equal to hex of 0b equal to int of 0b equal to Bala, did you understand or not?
Yes, sir.
Any question? Any question, Bala?
No, sir. No, sir.
Okay. Yes, tell me. Mona Lisa, right? You had some question?
No, sir, I'm just saying that why Python need this, that this is octal number, this is hexa. If we need to give
If
them
you order dosa, if I give you paratha, will you take it? Tell me yes or no.
no,
Then
but sir,
should you
these
not
are
should you not know whether I'm giving you dosa or idli or vada
no.
or paratha? Should you need to know or not?
Yeah, I need to know.
Then how can you work? If you don't know what data it is, how can you work?
Okay, all right.
Yes
I'm
or
just
no?
relating this thing earlier, which we had taught. We gave the command print and 3 plus 2. It's simple calculation. So there we don't need to say that what kind of number
Array,
is this.
daily if you use dosa daily. Like daily we are using integer, not a problem. But sometimes you
Yeah.
want to eat something different, is it not?
Yeah,
Right? So sometimes you
I
want to
got
eat
it.
something different. So that's why you are using this. Sometime you want to eat something different. Okay. So as long
Yeah,
as you are
understood.
using, um integer, it's fine. But if you want to use binary, how do you use binary? How will Python know that you want to use binary? So you have to put OB in front.
Okay.
Yes or no?
Yes.
Okay. Now let's talk about next operator, which is called as shift operators. Left shift / right shift. Okay. Left shift or right shift. What is left shift or right shift? Okay, we'll see that. So when you say left shift, what does it mean? Move towards left, correct? So it means move towards left. Okay, so somebody else joined. Okay, Kuldeep, yeah. So I'm saying left shift. So left shift means move towards left. What happens when you move towards left to a number? What happens to a number if you move left? So let's say you have 56 number. What happens if you move left? A number? Okay, let me show you here. So you have 56 here, right? I'm saying left shift. I'm saying left shift. So what happens? This, okay, so if you have two chairs here and you are sitting here and your friend is sitting here. Okay, if they tell you move here, what happens? So you come here, B will come here, and this is a empty chair. Correct? That means 5 will come to 100th position, 6 will come to 10th position, and empty space is created here. Yes, no? So left shift will multiply the number by 10. Yes?
Yes.
Everyone?
Yes, sir.
Yes.
Okay, left shift towards left. So if I shift a number, okay, to the left, a 0 is added at the end. Okay, now let's say I take 5, 6 and I say right shift. What happens? So this is your unit place, right? So 6 will fall
One
off. You fall off from the chair. Okay, and this will move here. So you get 5. Okay. So when you do right shift, the last digit disappears. So if I have 4,538 and I say right shift, then it is left with only 453. If I say again right shift, 3 will go away, you'll have only 45. Again, if I say right shift, you'll be left with only 4. Again, right shift, you'll be left with 0. So when you are moving towards right shift, your last digit is getting disappeared. If you do left shift, in the last 0 is getting added. Anybody, any question? Okay,
No.
this is your left shift and right shift. Okay, now coming back to our program. So this is exactly what left shift and right shift does. Only difference is these left shift and right shift operators work on only binary numbers. Left shift and right shift works only on binary number. Okay. So tell me, if it happens on binary numbers, then what will happen? Okay. Okay. So let's see how left shift is written. Left shift is written double less than. Double less than, when you see single less than, means it is comparison operator. You're comparing, is A less than B? Is A less than B? That's what we are comparing when it is single less than. When you have double less than, it means you are doing left shift. You are doing left shift. Similarly, right shift is double greater than. So when you see double greater than, you are doing right shift. Okay. Now, let's say I give print 56 left shift 3. 56 left shift 3. What you'll get? What do you think the output? Okay. So see here, I told you left shift works on binary. Okay. So what is the binary value of 56? Binary value of 56 is bin of 56. So binary value is 111 correct? So binary value is 111 and I'm saying left shift 3 times. Left shift 3 times. So one left shift will add 10. 3 left shift will add 3 zeros. So what you do? You add 1, 2, 3. Yes or no? Okay, you said 56. This is 56. Yes? 111 is 56.
Yes.
And I'm saying left shift 3. So I'm saying shift towards left 3 times. 3 chairs will be vacant. So 30 you add. Okay. Now this is the output, right? How do I convert this into decimal number system? I will say print int of 0 be this one. What is the equivalent of this? 448. Okay, this is equivalent of 448, right? So now if you do 56 left shift 3, you will get 448, or you should get 448. Let's see if we got it right or not. So see, 448. Did you get it? Now why 448? When you take decimal system, which has 10 digits, 0 to 9, 10 digit, okay, by putting 1 0, your number is getting 10 times multiplied. When you have binary 2 digit, putting 1 0 will multiply by 2. So when you say 56, 56 left shift 1 will give you what? 56 into 2. What's the value? 56 left shift 1 will shift 1 time. So your number will get doubled. That is 56 into 2. What is it? 56 into 2?
112.
Yes, 112. Now again I said, because 3 times you have to do, right? So 1 time you did, it is 112. Second time if you do, then 224. Correct? And then we still have to do one more time. 224 into 2, 448. That's why you get 448. So this is called left shift operator. Okay, left shift operator works on binary values. Okay, and this is what it would mean. 56 left shift means less than 3 would mean, okay, multiply 56 by 2 3 times. So first 56 into 2, you get 112, then again into 2, you get 224, again into 2, you get 448. Yes, no?
Yes, sir.
Now you tell me, if I perform 56 right shift 3, what will I get? Guess. Okay, of course, here I have to say 56 right shift 3, right? So guess me, tell me what will be the value? Decimal number you drop. You don't consider decimal number. You drop decimal number. So right shift 3 times by 2. 56 by 2? 28, right? 28, correct?
Yeah, correct.
28. 28. So that is 1 time right shift. 28. 28 by 2?
14.
14. 14 by 2?
7.
Right. So this will be your 7. Okay. Now if I make it 4, then what?
And 7 by 2 at the
7
end.
by 2. So I told you to ignore decimal. So you get 3.
Okay.
If I do again 5, then what do you get? 1. And again I do 6, then what do you get? 1 by 2. What do you get?
0.5.
Array, I told you to ignore decimal. No, you get 0.
0 then. Yeah.
If I do 7.
0, 0, 0.
Yeah. After 0, it's 0 only, right? 0 by 2 is 0
Yeah.
only. Right? So you can do up to 0. So this is your left shift. So exactly what happens is that this integer number gets converted into binary and you are dropping the value 1 by 1. Okay. So when you do left shift, number gets multiplied by 2. When you do right shift, value gets divided by 2. Okay. Ignore the decimal point, we don't consider. So when we did 56 by 10, okay, or 56 right shift in the decimal, we did not say 5.6, we said 5 only. You are dropping the value, you are not keeping it. So there is no decimal value here. You are simply dropping 1 by 1. So 56, when you divide by 10, it is 5, not 5.6. Okay. So this is how left shift and right shift operator works, and this has some significance, which is left shift will multiply by 2 and right shift will divide by 2. Okay, they work on binary numbers. There are two more binary numbers and we don't use it. Okay, we will not use it, but since we're talking about binary numbers, let's cover that up also. Okay, so these are called your bitwise operators. Okay, just like we have arithmetic, Boolean, logical, comparison, not Boolean, logical, right? Arithmetic operators, comparison operators, logical operators. These are called as bitwise operators. Bitwise. Why bitwise? Can anybody explain? Can you guess why it's called bitwise?
Work on 0 and 1 bit, which
Your voice is too far. I can't hear you properly.
I mean, will it work on only bits like 0?
Yes. Okay, it works on bits. So those who doesn't understand how bit works, what is bit? See, bit is the lowest level of data which a computer can store. Okay, so what is the lowest level of data that we can store in our natural language? One character, right? So one space is a minimum number of characters that you can store, right? Minimum is one character. So you can either say A, you can say B, you can say 5, right? Similarly, since binary languages use a machine, in binary you can use either 0 or 1. So 1 bit you can store only 0 or 1. Okay, so that's why it's called bitwise. You know, you're talking about 0 and 1, talking about each individual characters. So just like we have individual characters in English as 0 to 9 or A to Z or your special characters. So in computer, the smallest data is 0 or 1. Okay, so that's why when you say, so you know, an 8-bit makes 1 byte. Okay, so 8, okay, so 2, 3, 4, 5, 6, 7, 8, 8 bits make 1 byte. So you hear like kilobyte, megabyte, gigabyte, GB. B is byte. Byte is what? 8 times of bit. 8 characters together is actually one our English character. So generally, you know, one English character is equal to 1 byte in computer programming. Okay, and how many bytes can it store? So that's why when you say 1 byte, that means it can store 1 character. When you say 1 kilobyte, okay, 1024, okay, and 1024 into 1024, that many megabyte is that many characters. Into 1024 becomes your gigabyte. Okay, so like that counting starts. So it's called bitwise because we work on bit, one single character in binary number system. Okay, so bitwise you have left shift, you have right shift, you also have and or. And is written as ampersand. This is and in bitwise. Okay, logical and is written as a and d. Okay, but your bitwise and is written as ampersand. Okay, so ampersand, and this is a bitwise, and then you have something called as or. This is pipe. Yeah, pipe or in bitwise. Pipe is that sign above in enter on your keyboard. Just above enter, you will see there will be a pipe, straight line. That's called pipe. And this is the sign for or in bitwise. Okay, it's called or, bitwise and. Okay, so if I perform print 23 and 12, what do you get? So what it does is, first it will convert into binary. Okay, so let's first convert 23 into binary. 2, 3 and 12. Translate. So 23 is 10111, 10111, and 12 is 1100. Okay, it is 1100. Now this is 5 digit and this is 4 digit, right? So let's make it 5 digit here. So how to make 4 digit into 5 digit a number? You add 0 on the left, not on the right. If you do on the right, value will get doubled here, right? So you put 0 on the left side. Now both are 5 digit. Now what did we say? We said and. Now you're performing and on bitwise. We are performing bitwise and. Bitwise and means at every bit you're performing and. Okay. So what is 1 0? 1 and 0? Come on.
0,
0.
Zero.
Yes. 0 and 1?
0,
0,
1 and 1?
1,
1,
1 0?
1. Sorry, 0.
0. And
Okay.
1 0? Again 0.
0.
So bitwise and is 0 0 1 0 0. Now again we have to translate this into integer. So how do you translate into integer? You say print int of 0b, this binary, right? So 0 0 1 0 0. You can put 0 0 or you can remove 0 0. 0 0 on the left doesn't have any value. Okay, when you run it, you see it is 4. That means your 23 and 12 will give you 4. Okay, so you understood how we got 4? Let's see. We put it here and then we'll see. So 23 and 12 is 4 because each number is converted into binary and is performed on bit, each bit. Okay, and you get binary and that binary outcome is converted into integer. So that's how you got 23 and 12 equal to 4. We are not going to use, but again, this is very much useful when you are doing your password, this thing, encoding and decoding. Okay. Okay. So this is how you can do bitwise and. Similarly, bitwise OR. Okay. So if you do same, let's take same number and we'll say OR. Okay. OR. So what happens here? Okay. So in OR, okay, if I say OR here, so 1 0, 1 0, 1 or 0?
1, 1,
1. We said even 1 1, it's on 1. 0 1,
1,
1 0, 1 1,
1, 1, 1,
1 0,
1,
1 0.
and 1, 1.
Okay, so this will be 23 or 12, bitwise or 12 is going to be this one. Okay, you can put it here. So when you run it, you see 31. See 31. You get 31 here. Okay. Yes or no?
Yes.
Yes.
Okay. So this is called your bitwise operator. Kuldeep, Bala, Geeta,
Yes, sir.
any question?
No, sir, no.
No? Yes, please practice. You'll get it. Okay. So we are not going to use much, but this is very helpful, especially for those who are here for Python. Okay. For you, it is helpful. For data science, we may not use it again. Okay. But for analysis and sometimes encoding, decoding, okay, this is helpful. So for you Python folks, this is going to be helpful. Okay.
मेरे सर मेरा सॉफ्टवेयर नहीं सर डाउनलोड हुआ वो पाइथन और वो
ठीक है, तो क्लास के बाद अगर बैठेंगे क्लास के बाद कर लेंगे सॉल्व. ठीक है कुलदीप. Sure. Okay, so this is how bitwise works. With that, we finish our operator. We have finished our one important concept. I told you first few days, 6-7 days is important. So the operators is important. You need to understand this operator very well. But next couple of topics are little more advanced. Okay, I need full attention. One is your if conditions and then loops. Okay. Now, what is condition here? Okay. I think I do put insert. Yeah. So let's say I want to check. Okay. If simple, you enter a number. Okay. And I want to say if this number is positive or negative. Okay. If I have to check whether this number is positive or negative, what am I doing? I have to print both positive as well as negative, but not both at the same time. I have to check the condition. Okay, this is where if is used. If is used to check the condition. Okay, and if condition, okay, depending upon the condition, we perform certain action. Right? So in the next class tomorrow, we'll focus on conditions, how to check a value, and depending upon the value, how you perform certain action. Make sense?
Yes.
So we'll stop here today.